Hello friends, I welcome you in lecture number 38 on hypothesis testing. In this lecture, we will discuss one more question on hypothesis testing. This question was asked in GTU Winter 2021 exam. First, we understand what is this hypothesis test about, or for which population parameter we have to conduct this hypothesis test. A tire company is suspicious to claim that the average lifetime of certain tires is at least 28,000 km. To check the claim, the company takes the sample of 40 tires and gets a mean lifetime of 27463 km with standard deviation of 1348 km. Test the hypothesis at 1% level of significance. First, we have to identify the parameter of population which we want to test for this hypothesis test. So here you can see from this statement or this line that a tire company is suspicious to claim that the average lifetime of certain tires is at least 28,000 km. So here from this word average you can decide that this is the hypothesis test for population mean. Company is suspicious about the claim that average lifetime of certain tires, which we denote by mu, is at least 28,000 km. That is, population mean is greater than or equal to 28,000 km. So this is the claim, but company is suspicious about this claim. So company is suspicious about this claim. That means this population mean can be less than 28,000 km also. So the company wants evidence that this claim is wrong, that is population mean is less than 28,000 km. So this we will consider as our alternative hypothesis, and null hypothesis will be considered as population mean is equal to 28,000 km. Some authors or sources consider this as null hypothesis, and that is also correct, but we are considering equality sign in null hypothesis, and alternative hypothesis is that company is suspicious about the claim that average lifetime of tires is at least 28,000 km. So that means the company wants evidence that the claim is wrong, that is population mean is less than 28,000 km. So we have to test this null hypothesis that population mean is equal to 28,000 km against this alternative hypothesis, and because we have less than sign here, we will consider left-tailed hypothesis test. And for this, company has taken a sample of 40 tires, and company find the mean lifetime of these 40 tires is equal to 27,463 km, and standard deviation for this sample is 1348 km. So using this sample data, we have to test the null hypothesis that population mean is equal to 28,000 km, or average lifetime of certain tires is equal to 28,000 km. Here sample size is 40 and it is greater than 30, therefore we can apply large sample population mean test or hypothesis test for large sample this possible here. So, and we know that if we have large sample, the formula for test statistic is given by z equal to x bar minus mu divided by sigma over under root n, where sigma is the population standard deviation. But if sigma is unknown, we can replace this sigma by sample standard deviation. So here we are given all these values: sample mean, sample standard deviation, sample size. So using this data we can calculate the value of test statistic, and we have to conduct the hypothesis test at alpha equal to 1% level of significance. That is, we will consider alpha equal to 0.01, and now we try to calculate test statistic, which is given by this formula: z equal to x bar minus mu divided by capital S over under root n. Therefore z equal to sample mean of 40 tires is 27463 km. So here we substitute 27463, that is for x bar, minus value of population mean. If null hypothesis is correct, we put mu equal to 28,000 km. So here we write 28,000 km. Sample standard deviation is 1348. So here we write 1348 divided by square root of 40, and using scientific calculator I obtain the value of test statistic as z equal to minus 2.5195, or we can round off up to 2 decimal places, and we find the calculated value of test statistic as minus 2.52. So this is the value of test statistic. Now next step is to decide the critical regions. For that we notice that our alternative hypothesis is of less than type. Therefore we have left tail test and level of significance is 0.01, and we know that this random variable is a standard normal random variable. Therefore it has symmetric bell shape probability density curve. So first we roughly sketch the graph of normal distribution or probability density curve for normal distribution, and we know that it is a bell shaped symmetric curve. So suppose this is the graph of given normal random variable, and at the middle this value is 0. Mean of standard normal random variable is always 0, and we have less than type alternative hypothesis and level of significance is 0.01. Therefore we will consider 0.01 area in the left tail. So for example, suppose this much area is 0.01, then here also this much area will be equal to 0.01, and this point will be denoted by z suffix 0.01. Due to symmetry of this normal curve, these two areas are equal, and if we denote this point by z suffix 0.01, this point will be denoted by negative of z suffix 0.01. Due to this symmetry, we have equal area in both the tails, and we are interested in the area to the left of this point minus z suffix 0.01. We are interested in this critical point, and this is going to be a rejection region. So if we can decide the critical point minus z suffix 0.01 or z suffix 0.01, then we can decide the rejection and non-rejection regions. So now we observe from this table, this graph, that if we consider this point, probability that capital Z is greater than z suffix 0.01, then this is equal to area to the right side of this point, which is 0.01, and we are interested in the probability that z is less than z 0.01. So this is using the definition of complementary event. Z less than z 0.01 is the complementary event of z greater than z suffix 0.01, and we are having this probability, which is 0.01. Therefore we have 0.99 probability that capital Z is smaller than Z 0.01 is 0.99, or area to the left of this point Z suffix 0.01 is 0.99. So in the table of standard normal probability, we have to search for 0.99 area, and we have to find out the corresponding value of Z, which we have denoted by Z suffix 0.01. So I am going in the cumulative standard normal probability table, and I am searching for 0.99 area in this table. So here somewhere we can find out 0.99. This is 0.9918. We are interested in 0.99. So if we round off this value up to 2 decimal places, then we got 0.99, and it corresponds to this row, and here Z value is 2.3, and we have to find out the value corresponding to this column, which is 0.03. So 2.3 and plus 0.03, that is 2.33. So the critical value is 2.33. Z suffix 0.01 is 2.33. That means this value is 2.33, and this is also minus 2.33. Because we are having left tail test, we consider alpha equal to 0.01 as it is. If it is two-tailed alternative hypothesis test, then we have to divide this alpha into two equal areas by dividing alpha by 2. But here we are having left tail test, so we consider the area in the left tail, and this is going to be a rejection region. This part only, this is our rejection region. You don't have to consider this as rejection region. Okay, this is just for understanding. And here area to the left of this point is rejection region, and remaining part is non-rejection region. Now this value Z suffix 0.01 is 2.33, therefore this is negative of 2.33. Now this is critical value for this rejection region, and we have to compare calculated value of test statistic with this value. Calculated value is minus 2.52, and this is minus 2.33. So minus 2.52 can be somewhere on the left side of minus 2.33. That means we are in rejection region. Here we can write that since Z equal to minus 2.52 is strictly less than minus 2.33, that is minus Z suffix 0.01, we are in non-rejection region, and therefore we reject the null hypothesis. We reject null hypothesis. And